We do not have 15 to 20 years in total to change aviation.
When you think about the future of the aviation industry, I think most of us at the moment have in our minds the image of an electric VTOL. So a vehicle that's battery powered and taking off vertically, transporting a handful of people. As fascinating and novel as this technology is, it unfortunately does not have the potential yet to transform the aviation industry as we know it today. Here, hydrogen seems to be a much more likely candidate. But in what way should hydrogen best be used? Should it be used in synthetic fuels? Should it be used in a fuel cell on board of the plane to then power an electric motor? Or should it best be burned in a gas turbine? And since we already talk about it, which of these technologies could be implemented fast enough to have an impact on climate change while also making the most sense economically? Stay tuned and you will get the answers in this episode. Welcome to the Smartery Podcast, a podcast for and with the creators of the new energy world. A world in which energy will be renewable, decentralized and digital, bringing together electricity, heat and mobility. Let us show you how we will get there and who will get us there. My guest today actually has written a little bit of aviation industry in his own right because he and his team were behind the very first fuel cell aircraft which took its maiden flight in Stuttgart in 2016. I'm very honored to welcome Professor Josef Kallo of the German Aerospace Center, the University of Ulm, and most importantly, CEO of H2FLY. Welcome, Josef.
Thank you very much for having me.
I already mentioned that you and your team managed to have the very first fuel cell powered flight globally. So that was an absolute stunning premiere. What I think is interesting, and just to contrast it here, is that a year before, I think another professor from a university in Stuttgart managed to fly across the Alps in a purely electric powered plane, a small two-seater, I think. Also, there's, in the press, when you look at, there's so many politicians being pictured next to air cabs who are also powered by lithium batteries. I know that in your CV, I saw that you actually also worked and researched lithium batteries. So why your choice on specifically hydrogen and fuel cell powered drivetrains? Why do you, and then of course also a lot of colleagues in your industry, think that this is the solution for air traffic? Like, what are the advantages here over lithium batteries?
So with the hydrogen electric powertrain, we combine the low noise capability of the electric propulsion system and at the same time the very high energy density of the hydrogen, which is 6 times to 10 times higher that we can achieve with batteries. So at the end, we aim for a middle range from 2,000 to 4,000 kilometers and to a very low noise aircraft.
So in short, in my non-expert understanding, that means higher energy density also probably means a lot less weight.
So with the same weight, we can go 6 to 10 times further than with battery-driven aircraft. And that is the challenge today with a pure electric powertrain. But we see that this can be done for a much longer range.
So you already mentioned the ranges, I think 2,000 to 4,000 kilometers. So that's so rather not the short, but more like medium haul routes or intercontinental flights, right? On the long perspective.
So at the moment, we see that the technology as it is today has the possibility to give us ranges between 2,000 and 4,000 kilometers purely with electric hydrogen powertrains. That means that the hydrogen the energy of the hydrogen is converted by a fuel cell into electricity, which then uses an electric motor to fly. So in our case, what we see is that we can go on missions between 500, 700, 800 kilometers, even up to like 1,500 kilometers. And then having a round trip of more than 3,000 kilometers without establishing on every airport a new infrastructure.
That's already some amazing numbers, and I think we'll go into the cost competitive more towards the end of the podcast. Let's start with a big context first. I mean, of course, we all are aware that air traffic is a huge problem when it comes to emissions. I think globally, It's only 3% of the global emissions. There's other sectors that are much more pollutant. Still, it's a significant number and a significant level. So how much CO2 could actually be saved if, fuel cell power drivetrains would make it into aviation on scale?
So what we see is that even the 3% of the global emissions which we have out of the aviation are important to save. So with the electric fuel cell powertrain, converting the hydrogen to electricity and then to movement, we see the possibility, and now I'm thinking the whole chain from the hydrogen production to the hydrogen use, we have a possibility to save up to 75 to 90% of the CO2.
And that also includes the transporting, the trucks, transporting kerosene so far, or even the drilling of oil, I guess, the whole value chain, That includes the whole value chain, correct. Let's have a look at the technology itself. I think because what we're talking about at the moment still is sort of theoretical in the sense that there's pilot projects, but it's not a mass product yet. So where are we at now? I know there's many companies and scientists that are researching CO2 neutral flying with H2. Even some of the three most relevant players, I think, come from Germany, like German Aerospace Center, Zero Avia and Airbus. So what are the most exciting results as of today?
So we work since 2007 on this technology, and at the moment we work on the 7th generation of hydrogen electric powertrain. And from the 6 generations, we learned that we can have functionality in an aircraft environment, but at the same time, the qualifiability and the possibility to go into certification is also given. So this is a very important outcome, which we are using now to head off for products.
That sounds like we do have necessary technology to really then go into aircraft construction, like leave the pilot setting and really go into main production. Or is there something still missing in concrete terms for the implementation?
So what we see is that the next step is the upscaling of the power which we need out of those systems. If we want to have a real contribution in aircraft transport, we have to leave from 100, 200 kilowatt systems and go into bigger systems in the megawatt range. And there we have now to develop the components. So from a functionality point of view, we know that it will work. We know also what is the right architecture to have a certified system. But we have to take a deep dive into component redevelopment and component optimization on the megawatt scale.
On the megawatt scale, just once again, as me as a non-expert, an industry outsider, that means I imagine a big Boeing in the airport that I would take to, fly in my holidays in Bali, that big engine that you need to replace in that Boeing. That's what we're talking about.
So that is the masterclass, I would say. We are aiming for the regional aircraft and for the medium range aircraft, which at the moment are 40, 60, 80, 100-seater. And therefore, 2 systems per 1.5 megawatt will be completely enough. So we will have a classic twin configuration, and we have a chance with that to use also knowledge from today's design of aircraft.
Well, let's imagine that you successfully scaled into that size and you're able to provide a plane of that size, an 80-seater with the necessary engines. How would the hydrogen get into the tank? How far are we from actually really being able to supply any airplane anywhere in the world with hydrogen if necessary?
So this is a very interesting question. I think we should start delivering hydrogen at the most important and most valuable spots where we need to introduce hydrogen power planes to minimize the emissions. I will not talk about worldwide instantaneously. So we see that even if we take like 6 to 7 spots worldwide, we could do a major contribution to the emission lowering. So with that in mind, I would say the hydrogen infrastructure technology is already there. What we need are investments to get this into a broad mass.
Into a broad mass. And I guess then, of course, we're not going to dive into that because we covered in other episodes. We simply also need enough hydrogen in this world, or in Europe as it is. But that's a very different topic, and hopefully we'll have it solved by the time then the airplanes are ready to take off. But still, what might the necessary logistic chain look like for hydrogen aviation? Like, who would be the relevant players? Would that hydrogen, for example, come from the MENA region to Europe, let's say? Would we be able to produce it here, right next to the airport maybe? What would you envision?
So what we have seen is that the energy need, so the mass of energy which we need to have aircraft propulsion is so high that we need dedicated renewable resources, which from our perspective should be centralized in a gigawatt range. So we need electrolyzers which work in a gigawatt range, which can deliver very, very efficiently and most important, very cost efficiently the hydrogen. And from our perspective, we see that there are worldwide possibilities to install photovoltaics and wind dedicated for producing hydrogen for aviation.
So you would not be able just to set up your own electrolyzer next to the airport and plug it into the grid, but you really need to think through the whole value chain, even from starting with producing dedicated renewables. But what time span are we talking about? And maybe while you give us a time span, I know, for example, that I think for 2025, that's the deadline you set yourself to get a 40-seater Dornier into the air being powered with a fuel cell drivetrain. And so what time span are we talking about if you think we really could have a significant fleet of airplanes in the air? And how do they relate to hydrogen already being used as synthetic fuels nowadays, or maybe even hydrogen being used in gas turbines? So how does it relate to other ways of already using hydrogen in aviation?
So I think we have to differentiate, first of all, regarding the fuel. So we see that if we have the hydrogen on board of an aircraft, we can use gas turbines to burn the hydrogen. But at the same time, we can use the fuel cell to have much more low noise in the aircraft and much higher efficiency, which less emissions. So we are not thinking using the hydrogen for synthetic air fuel because the efficiency of the synthetic fuel production is so much worse that the direct use of the hydrogen that we will not have enough renewable power installed to cope with the demand of that energy. Regarding the technology roadmap, we think that in 2025 there is a chance to have a demonstration on the CS25 40-seater. We have a partnership regarding hydrogen technologies and fuel cell with Deutsche Aircraft out of Oberpfaffenhofen. And what we see is that it will take after that round about 4 years. So at the end of the decade, we can say that we will have a certified, ready-to-go 40-seater or bigger aircraft.
So by the end of this decade, and then of course a couple of years until you really have a significant number of airplanes or a big enough fleet. So we're talking somewhere mid-30s to 40s until we see really a higher number of airplanes in the air. Because I guess also you don't want to decommission very asset heavy airplanes unless they are actually old. So I guess it will take some time to just turn around the fleet as such.
Yes, but there we have to do something. So definitely we can retrofit aircraft. So there are some which can be retrofitted with this system. That's a major challenge, but it can be done. What we see is that we do not have 15 to 20 years in total to change aviation. So we are aiming for technology development until the middle of the decade, but then very strongly focusing on the certification to start then directly with the production of the powertrains. And in that case, we are looking for partnerships, not even for the 40-seater, but also for bigger aircraft.
How does it? I'm still gonna ask because that sounds. It's more like it's not near future. It's more on the long term, and that's the ideal scenario. You said there's just so many reasons for not going for synthetic fuel, but for actual fuel cell powered drivetrains. But I guess there will be an overlap of where we can use hydrogen now, just in existing engines, existing airplanes to reduce emissions now. So is it that we will focus on synthetic fuels until the new era of engine is available? Or is it that we have to make a decision? Because if we go down the route of synthetic fuels, we just invested so much in that infrastructure that it sort of would take away the incentive for really getting hydrogen-powered airplanes in the air.
So this is my personal opinion. Going the roadmap with synthetic fuel will very soon show that the energy demand to produce the synthetic fuel is way much higher by 2 orders or 2.5 to 3 orders higher than the production of hydrogen. And to really make a difference, and I'm not talking about marketing or pilot plants, by really making a difference with the synthetic air fuel, we would need 3 to 5 times more installed renewable energies that we have overall today in Germany, only for the aviation in Europe. So if you take those numbers and look at the numbers, then you will see very fast that after some short, small pilot power plants, there will be no cost-effective production of synthetic air fuels from an energy perspective, but also from a cost perspective.
That's a very interesting fact because to me, what I understand is that synthetic fuel doesn't make any sense because it is, as we said, just 3% of global emissions. So I guess it would make sense to dedicate those renewable energies into other industries and other sectors. Use airplanes as they are with kerosene, although it doesn't sound sexy or it's not good for marketing, certainly, but to just wait it out until a completely new generation of airplanes is available or could be retrofitted.
So what I can say is definitely we have to refocus from gas turbines and using synthetic fuels or kerosene and focus very, very strongly on the production of hydrogen as a fuel in industrial scale, not on marketing pilot power plants. And a second point, we have to focus on the technology development of the aircraft propulsion systems. I think from an integration perspective, we have already very efficient concepts today. I will not go with fancy new aircraft. I will use today's concepts for aircraft buildup, but then we have to focus on the development of the powertrain and the integration questions and the certification questions. And from my perspective, I have to say we should definitely use today's technology as long as we have to, but as fast as possible, change to hydrogen electric propulsion.
That does sound reasonable. It usually really also makes sense to just have a very clear focus when it comes to future investments and not get lost in too many different ways. So what are the expected costs we're actually talking about with a series produced H2 aircraft compared to a conventional aircraft? Is it going to be a lot more expensive? Are there maybe even synergies? What's your estimate?
So what we see is that we have to compare, as the Germans say, apple with apple and pears with pears. So we have to compare where is the energy coming from. So when we think about renewable hydrogen and we see the development of the energy delivery cost, which normally in a synthetic kerosene has to be also taken in account as much as with the hydrogen. But also when we compare that with the normal fossil kerosene, which nature was producing for us for free in the last couple of millions of years. Then we see that taking all that cost in account and the CO2 abatement cost, we definitely have a chance to be cost effective in the same range with the hydrogen fuel cell plane and from a fuel perspective. Definitely, we have to take in account that we have to do the new technology development, but I would like to encourage the calculation of the number of the full chain. So taking the energy production, the energy distribution, and the new technology development. And then we will see very shortly that the hydrogen path can be a very efficient way to have new technologies, emission-free technologies at very low cost.
I think that's really important because, I mean, of course, aviation industry is a very cost-driven industry, very price competitive, and they rarely touch technologies that increase prices in the short term. So I guess that's a very important factor, the cost effectiveness. Is it still a topic of debate in the industry as such? Are there strong advocates for example, electric-powered airplanes still, for whatever reasons or arguments they may have? Just as we see it in the car industry, you know, there's still some go for synthetic fuels, some for hydrogen, some for batteries, depending what company they represent. Is there an even similar scenario in the aviation industry, or do you all agree?
So it's as always, we have not only one stream, we have more than one stream. So what we see is that the battery-driven applications, which can go 100, 150, 200 kilometers with smaller planes, with eVTOLs and so on, those applications have a possibility to open up the markets. So those applications, they take care that the electric powertrain, the integration of the electric powertrain, and also the certification of those powertrains, battery with electric motor, that they are done and they are pushed very, very hard forward. And as always, we profit from that development when we open up the range. So now imagine you have in the next couple of years, 2 to 3 years, you have a battery-driven small eVTOL, which goes also very fast, 200 knots as an example. And then you have another technology on top of that, which allows you in 3 to 4 years from now to go not only 100, 200 kilometers, but maybe much more. So I think the market will take it. So from that perspective, we definitely see that technology drivers, even they start with technology which does not give you the full potential of that hydrogen electric powertrain, are needed to push forward. And in this case, I'm very pragmatic. I think if we can show that we can go 5 times, 7 times, up to 10 times much more in range, then we definitely will have a market.
So I hope I'm not putting this into oversimplified terms, but that means what we're actually talking about is certainly the electrification of the engines as such, and then depending on the range, either the source is an electric battery or a fuel cell to power them.
So from our perspective, there are multiple missions. If you want to fly 30 kilometers, 50 kilometers, 100 kilometers maybe maximum, then the battery will be ready to go in the next 3 years, 2 years, 3 years. But if you want to have real individual mobility, very fast mobility, connecting intra-regional and inter-regional destinations with a very short time, so times which we are not used to at the moment, then we definitely will need the hydrogen.
So that's really interesting. Thanks so much, Josef. We've already gone way over time, but it was so interesting to talk to you. What's really important, the timeline. I know it's not your strategy advisement, but that's at least what I got from it. It does not make sense to hugely invest into synthetic fuels at the moment, just then to switch over to fuel cell powered aviation. On the long run, it would make sense to just take all that investment and go in that direction right away and just wait out the time we need to get there. And as you said, it's not that far away. In 4 years' time, we're talking about the first pilot flights. Then a couple of years later already, you might be able to have it certified and to go into production. And then in the mid-30s, somewhere we would be able to really have a significant changeover in the existing fleet. I think those are the most important takeaways. Also Also important, of course, here in the context of the smarter E, it needs a dedicated value and production chain. So we need dedicated power production sites for renewables just for the aviation industry. And what's also important is that the distribution network as such would not be that complicated to set up. There's already a big network in place. And I guess it would just be necessary to start with the important hubs and then, as the time goes by, break it down to smaller hubs. Thanks a lot, Josef, for having joined us today.
Thank you very much.
For more information on green hydrogen, visit the Smarter E Europe from May 11th to 13th in Munich. In the Green Hydrogen Forum and Expo exhibition area, cross-industry and cross-sector companies from all over the world will meet to accelerate the introduction of hydrogen, fuel cells, electrolyzers and power-to-gas to the markets. Tickets can be found online at thesmartere.de.